местный интернет не дает покоя.
For the delay, just a second. So, hi everyone. My name is Nikita, and I'm an addict. I'm addicted to functional programming. This might be weird to you because this is a Java conference, and you might ask, what the hell am I doing here? The reason is that, as many of us, we have to do deal with different technologies during our work days, and recently I had to work with Java, and the problem that I had was integration with database, the typical problem that we experience usually on a daily basis. But when I approached it, I discovered that none of the existing solutions satisfied me, and having some background on working with libraries that implements integration with databases, having quite a background with this because I've been working on such libraries for Scala and for Haskell before. I decided to just implement some simple abstraction over the Jdbc, and this talk is going to be about it. So this comes from my background. First is the link to the Haskell project that inspired most of the design decisions in this library. But don't be afraid. Despite this being a functional language, I did not make this library look like a functional kind of thing too. It should be just a typical Java use case that we are all used to. Also, I've done the SORM ORM library for Scala before, but lately I'm kind of getting out of supporting this, finding other people to do this. But either way, this gives some perspective from my experience before. And this hasql library actually is used by this popular, the lately growing popular project Postgrest. It powers it internally. The first thing I want to cover is the subject of complexity. I'm pretty sure that many of you know this guy, Rich Hickey, who is the author of the language closure. And this guy, I absolutely adore him. I recommend you all to watch his presentations because each one of them is absolutely marvelous. He covers the subject really great, and in many of his talks, he talks about simplicity and complexity and how to approach our problems generally, not just in the context of closure, but in a general context. So I definitely recommend watching it. And during this talk, I'll be making a few references to it, to his talks. One of the most important part of his talks that I'm going to refer to is the problem of complexity. By his definition, we could simplify it. The complexity is the amount of problems that we have in our programs which are intertwined, which are twisted together, coupled, if you say so, which we cannot review in isolation. And those are the cases that make our software hard to maintain, prone to introduce bugs and all the standard maintenance problems that we often discover. And Rich Hickey gives a great analogy of complexity with juggling. The reason is that we are people, we are mortal, we are limited in our capabilities. We can only do a certain amount of things at the same time, and we can only think and consider a certain amount of problems at a time. It is kind of similar to juggling, because, well, the best jugglers in the world can do how many? Maybe 7, 10 balls at a time, but not more. There is a certain limit to it. It, of course, depends on the capabilities of a particular person, but either way, it is limited for all of us. And the same applies to us thinking and reviewing concepts. Juggling can, of course, be different kind. It can be harder. It depends on the context. I mean, there can be some problems that make your ground shaky, and this gives a good analogy in my case. Sometimes it's even like this. I want to review the problems of Jdbc. Right now, just a second. I'm gonna try to squeeze this into the view. God damn it. Well, either way, hopefully you see the most. This is a typical example of a Jdbc code that I grabbed from the internet. You can see a lot of things happening here. I mean, we have the SQL statements, we establish some parameters, we deal with connection, we try to establish a transaction, we do commit it or roll back, depending on the exception. And we always have to monitor that we close the resources appropriately, because if we don't, we get a resource leak. And that's a terrible problem. That's a bug that no compiler will spot for us. And it's, well, in production, we can only discover it in production. It's hard to test against it. In this slide, I'm demonstrating the separate kind of families of problems that we deal with in this code. So first problem we can see is that we have to consider which SQL statement to execute. Then we need to consider the connection that we are going to be executing it on. Then we set this auto commit thing, which is actually establishing a transaction. Then we pass parameters to this statement. Then we decide how to execute it depending on which SQL we execute there. Then we do commit. Then we decide whether to roll back, and then we need to properly close the resources. So there's something like 8 families of problems just in this single piece of code, which the only thing it does is just execute 2 statements. That's really too much for us to comprehend. And this code didn't even include any code which deals with processing the results of executing the statements, because both of the statements were updates. And you can just imagine what the complications would be then. And it doesn't deal with such a typical problem like having, instead of a single connection, having a pool of them. And you could see that the code was highly coupled. We couldn't take any piece of it and review it in isolation, and it makes it a tough target to maintain. And at least 4 of those problems were a terrible bug pit. There can be, well, most of them were involved either deciding to either roll back or deciding whether to close a resource. All this, if we forget just a single statement, we have a leak and we have a bug. And no compiler will spot this for us. So the conclusion is Jdbc is complex. There's too many problems that it makes us deal with. And then, if we have already established that it is complex, we need to solve this somehow, and the typical way for us, the masterminds of solving problems is to abstract, of course, because there's a lot of patterns in this code, and we somehow need to move away from them. And the typical solution that most people arrive at when considering this problem is why not, if we are going to be abstracting over Jdbc, why not abstract over all the things that deal with SQL? I mean, why not abstract over SQL completely? And then those people arrive at ORMs, but ORMs are wrong. ORMs are wrong conceptually because there's too many problems that arise when we try to bind those two completely different universes of types and values that object model and relational model are. And generally, those problems are grouped in a term called object relational impedance mismatch, and it is a known and established fact. You can review tons of materials on the internet, and there's actually a great article on Wikipedia, if you don't trust me, of course. And this means that there is no unambiguous way to map between those two models. Whenever things start getting complicated, I mean, whenever you have a collection introduced on the Java side or a joining of several tables, things start getting messy whenever you use an ORM. You end up writing a lot of configs or manipulating your code in such ways that you would walk around the limitations that the ORMs introduce. And then there's another problem that actually it's not our applications that determine which way the database should be structured. It is the database itself. And a typical example would be that in our system we would have several components addressing the same database. And it's not for the, in this example I have a Java application and a Python application addressing a same Postgres database. And it's not for either of those applications to decide how the database should be structured. So it's for them to act as a client of this database, model the structure of the structure of this database locally. And in the end, ORMs end up being an over-abstraction. All the abstraction that it provides, while making things easier for us, it cuts a lot of features of those databases. You lose functionality in the end, and that's definitely not worth for us whenever we deal with some real complex applications, whenever we need to squeeze the power, all the possibilities of the database. So, in conclusion, while they make things easier, they make things harder. So, getting back to the problem of abstraction, we need to decide to find the boundary at which we should stop abstracting, at least while working with while solving the problem of mapping of values. And it turns out that we can safely stop at the level of primitive values like integers, booleans, strings, and whatever the types that the databases have. And we have a lot of native types that we can safely translate from the types of that the databases have. And those are just a few examples of those. We should not abstract over SQL because SQL provides us power. We can do a lot of things using SQL. And whenever I've seen people doing DSL, so somehow trying to abstract over it, they either end up re-implementing something similar as SQL, or they just cut down the features. So the conclusion is the best we could achieve is the compile time checking of those SQL statements for correction, for correctness, and that's about it. Apart from that, we should not change their structure. And thus we arrive at the library that I'm going to be discussing. It's just a simple wrapper around Jdbc, which introduces a few quite simple abstractions, and I'll show them right now. So first, the most basic abstraction that there is in this library is the statement abstraction. Here is an example of a statement declaration, which includes the declaration of the SQL statement to execute, a specification of how to encode the parameters that will be passed to this statement, and a specification of how to decode the results that we get from this statement. Everything, as you can see, is grouped in a kind of a declarative way, similar to how you would see HTML code or XML code or JSON or all those static formats that you have. And this is actually the reason why this variable that I assign this statement value to is final and static, because it won't change during the runtime of our application. It's just declared, and it will be like this. But it is possible to change the parameters while executing this statement. And I'll show how to execute it later. Getting back to this, you can see that statement is parameterized by two generics. The first one, the first parameter is the type of the incoming parameters. In this case, it only has the ID, which is integer. And the executing of this statement will result in an optional of big decimal, which is the type of balance. And all the encoders and decoders are declared according to those types. So everything here is type safe, and it's checked. But then arises the question, what do we have to do when we have multiple parameters? And in this example of code, I specify this type modify balance params, which is simply a value object which groups two values which will be passed to this statement. Those values are ID and balance. Apart from that, the rest of the code is pretty much understandable. But then this thing can actually be abstracted over. I mean, if you would, I don't expect you to be happy about introducing a class for each statement just to be able to pass the parameters to them. And this thing is easily abstracted over using the typical solution from the functional world, which is called the product type or tuple. In this case, I'm using the standard Java library, a quite popular one. I'm pretty sure a lot of you know about it. It's called functional Java. It has the namespace FJ, if you've ever seen it in some code. And it exports a lot of product types, which are quite similar to modified balance params, but they just have those fields as generic parameters, the types of those fields. And we just specify those types in the type signature. And in the implementation of the encode params methods, we just address those parameters from the product. So in the end, we get the statement which is an absolutely encapsulated abstraction. We don't, after declaring a statement, we don't care which SQL it has, how to encode or decode its parameters. We just can forget about this. This is a solved problem for us, and this is an absolutely isolated code. Then there is the abstraction over transactions. What it does is solve two important problems. One problem is that whenever you execute a transaction, you can expect a conflict to arise. For instance, in case of Postgres, each time two conflicting transactions which address the same row, for instance, two updates, you execute two updates to the same row from different processes, and they conflict. And this results in one of those processes receiving 40,001 error. And, well, a lot of applications don't expect that. The typical solution to this is to re-execute this code, which has been just, received this error. That's simply rolling back this transaction and retrying it again. And another property that the transaction abstraction has is the composability. Composability means that you can nest transactions inside of each other. And here's an example of a simple transaction of a typical case where you want to transfer some funds from one account to another. At the first method, we specify that this transaction requires the serializable isolation level. This is quite simple. And with the second method, we specify which statements to execute, those statements that we've declared before. And you can see this modified balance statement being reused. We simply refer to this value here and pass the parameters in those product types. And here's an example of composition of transactions, of how you can nest one transaction inside of another. This is quite a dumb example, I would say, but it shows how you can reuse an existing transaction, the transaction which we've just declared, the transfer run. And here we specify that we will need the same isolation level that the transfer transaction has. And in the body of the run methods, we specify what actually will be done during this transaction. There is a certain limitation to this approach, which is that inside of this run method, you should not do any side effects. By side effects, I imply addressing a file system, printing something, changing something in the outer world. The reason is that the body of this method might get executed multiple times, which will be in the case that I've discussed before, in case of transaction conflicts. This is why it's best to just have here a code which deals with database or simple calculations. And then we end up at the outer level of our application, we would have the so-called DAO object, which would simply abstract over all the functionality that we have there in our application, over all statements and transactions. And there we use the pooled abstraction, which simply establishes a pool of connections, and we specify how many of them we would want. And then we just specify a few simple methods which wrap the execution of transactions or statements that we had. And on the use side, a code would look like this. In this example, I create 2 accounts and receive the identifiers of them, and then I use those identifiers to make a transfer, and then I assert certain things that have changed about the states of those accounts. This is how you can install this or depend on this library. Basically, you've seen just everything that's about it. I can now show you the actual code of the library if we have time left. Do we have time left? No moderators. Okay, we have. I assume. All this code that I've shown you, it comes bundled with the source code of the project. I don't know how to magnify this though. Does anybody see anything here? No. Either way, you can see all this code, all the examples that I've shown you on the GitHub repository of this project. It's all in the tests, in the test suite. Basically, this sums it up. So thank you all for your attention. And questions, please. Yeah, please.
Thank you for your report. I have one question to you. There is one oldest library, like a Spring Jdbc. So why do we need to use your library instead of it? So if Spring Jdbc already contains raw mapper, Jdbc template, and so on. Thank you.
So on was the best part. Thank you. So the question was, why didn't I just use Spring Jdbc, right? Because this thing is simple. I mean, you don't need to configure a lot. You don't need to implement it a lot. It's all there. All the code that I've shown you, it's all you need. It makes things simpler. Actually, that's another point that I didn't bring up. This project is just the basis. I plan to evolve it as an ecosystem, and there are a lot of possibilities. There is a lot of possibilities to make the code even smaller due to utilizing functional stuff. We can make a DSL which would wrap the mappers specification, the encoders and decoders. Things would look neater. And I plan to release it as a separate library, which would be something like djdbc DSL, something like this. Did I answer your question? Thank you. Yes, please.
Thank you for the speech. And I have a question about transactions. So typically we declare transaction, we begin and commit transaction not at DAO level. We start transactions earlier at services layer. But as I understand, your framework, your approach doesn't give such possibility.
Can you repeat this, please, because it was tough to hear.
Okay, typically in many applications we begin transactions at services layer, not at DAO layer. And as I understand, your example shown only like DAO level transactions. So what if we need to have wider transaction?
Yeah. The reason is that actually it's best practice to have transactions as small as possible, because you don't want to have locks being set on certain tables or rows for a long time, which is why they should be as small as possible. And this code is just enforces the proper style on you. You cannot begin a transaction, you simply don't have access to this. Yeah, you only specify the body of the abstraction, and the beginning and closing and committing, rolling back, everything is abstracted from with this API. You just specify what happens inside of it, and you cannot have any side effects there. It might sound quite restrictive at first glance, but in practice, it's been tested. I mean, this abstraction is used in Postgrest, this huge project which does RESTful API over Postgres, and it's used there successfully. And I've used this abstraction in production quite a lot. I mean, not this particular project, but the same approach which was used in the original Haskell library. And another thing, I forgot the other thing. Let it be enough, I think. Is that enough for you?
Yeah, okay, thank you.
Thanks. Any more questions?
Please raise your hand. I will find you anywhere, anytime.
No more questions, I think.
Okay, no questions?
Thank you.